Now we are going to discuss about outer join. In that left outer join, right outer join, full outer join. See what is outer join? Outer join operation is an extension of the join operation, so that avoids the loss of information. Okay, outer join contains matching tuples that satisfies the matching condition. Okay, along with some or all tuples, some are all tuples that do not satisfy the matching condition. So it is based on both matched or unmatched tuples. Okay, both matched and unmatched tuples. It contains all rows from either one or both relations, one or both tables. It contains all rows, okay, are present. So now it uses null values, it uses null values also. Here null signifies that the value is unknown or doesn't exist. Null means what? Is unknown or does not exist. So outer join, how we can define outer join means it is the combination of natural join and extra information. See, from left table, right table, or both tables. That's what it is going to do. That is the outer join. That means from left table left join, from right table right join, right outer join, from both table means full outer join. There are three kinds of outer joins: left outer, right outer, full outer. When applying join on two relations means two tables, some tuples R1 or R2 does not appear in result set, which does not satisfy the join condition. So if join condition doesn't meet the condition, join doesn't meet the condition, if doesn't meet the condition, so there will not be a data, we will not get any data. So when applying join on two relations, two tables, the rows from R1 or R2 does not appear in the result set, which does not satisfy the joining condition. But in left outer join, all the tuples from the left relation, all the tuples means all the rows from the left table are included in the resulting relation, are included in the resulting relation. The tuples of R1 which does not satisfy the join condition will have values as null. See ma, here I have a table, table 1 and table 2. If the values are available in table 1, that values are not available in table 2, then the result will be what? Null. Okay. See, all records from the left table, one matching record from right table. Okay. See, symbol is what? For left outer join, what is the symbol in relational algebra? This is the symbol. Okay, so we can represent notation. This is the notation, and see the example, then you can understand. You have two tables, course table and HOD table. Course having course ID, course name, and HOD having CID and HOD name. See how we can join course and HOD. So this is the symbol to represent left outer join. Okay, see here CID, C course and name. See the IDs 100, 101, 102. Here 101 is available in this CID, no, right? So what is the left outer join meaning? It having the data, all data from left table, all data from left table. If the value, matching value is not available, if the matching value is not available, then the result will be null. So it considers null value. Are you understanding? In course, if you join course and HOD, so our data left table all data is available. Left data all data we have written here. Okay. Then related columns data. 100 name is what? Rohan. And 101 name is what? No, here not available. In this table we don't have name of 101. So that it considered as null value. Considered as null value. So 102, here 102 we have that name is Sarah. So data available. If data is not available, that will be null. Okay. Are you understanding? Right. In this way we can perform left outer join. Next, right outer join. That means what? Right join means right table all data we can display, and which are not available in the second table, that will be null. See, we can see here. In right outer join, all the tuples from the right relation are included in the resulting relation. So the tuples of R2 which do not satisfy the join condition will have value as null. If it doesn't match, that value is what? Null for attribute of relation R1. So in short, all records from the right table. So we can display all records from right table, only matching records from the left table. Okay, that's we know. What is the symbol for right outer join? See, right outer join, this is the symbol. So right outer join, this is the symbol. Okay, you represent this symbol means that is right outer join. So this is the notation. Two tables R1 R2, the relation R1 and relation R2, we are performing right outer join operation. See the example for right outer join. We have course table, HOD table. We are performing right outer join operation. See the symbol. That means what? So CID 100 102 right outer join right table. So this will be available here. So 100 available. Okay. So 102 available. 104 not available. Then the result will be null. Okay, so that's what we have written here. Are you understanding? So that means provides the right table all data and which are common to the second table, and if we don't have any matching value, then it is going to be null. Okay, next thing is what? Full outer join. All the tuples from the both left relation R1 and right relation R2 are included in the resulting relation. Okay, both tables result will be available. The tuples of both relation means the rows of both tables R1 and R2 which does not satisfy the join condition, their respective unmatched attributes made null. Here also, if doesn't have any matching values, matching attributes, so there the value will be null. Okay, if it doesn't satisfy the join condition, their respective unmatched attributes are made null. Okay, all records from all tables, in shortcut we can say all records from all tables. This is the symbol to represent full outer join. This is the symbol. Okay, This is the symbol to represent full outer join or full join. Okay, see the diagram. This is the diagram. That means we can display all the data. From we have two tables here, course table and HOD table. We are performing full outer join operation here. If you perform full outer join, both tables data must be available. Here data 100, 101, 102 and 104. Okay, if 100 we have the data. Okay, 100 we have the data. Next to 101, 101 we doesn't have data here, right? So that means the result will be null there. 102 is available, so we have the data, so there is no null. If 104, see 104, 104 having the data, so no data available here, so that means the course will be no course available, the course will be null here. So in this way we can perform left outer join, right outer join, full outer joins. Okay, see, this is the symbol. Okay, this one is very important now. This one, if you are writing exam, you need to represent this one. Okay, left outer join, sorry, full outer join. This is right outer join. This is left outer join. Okay, left. That's it about the relational algebra. So today we are going to discuss about the relational calculus. Okay, relational calculus. What is relational calculus? So relational algebra is procedure query language, right here. So see here, if you are trying to find the differences, you can find here also. So relational calculus is non-procedure query language. In non-procedure query language, the user is concerned with the details of how to obtain the end results. What we are performing here, how to obtain the end results. So the relational calculus tells what to do. What is telling? What to do, but never explain how to do. The relational calculus about what? It says what to do. It will not explain about how to do. Okay. We have two types of relational calculus. Two types of relational calculus. First one is what? Tuple relational calculus and domain relational calculus. Tuple relational calculus and domain relational calculus. Tuples means rows. Relation means table. Rows table calculus, and domain means range, integer or character. So that we can represent in the domain relational calculus. Right. So we have two types, TRC and DRC. TRC means tuple relational calculus and DRC means domain relational calculus. Okay, TRC. Coming to TRC means tuple relational calculus is specified to select the tuples from the relation. Relation means table. It selects the rows from the table. In TRC, filtering variable uses the tuples of the relation. Tuples of the relation. The result of the relation can have one or more tuples. The result will be one or more tuples, one or more rows. Okay. What is the notation? How I can write? Say T vertical line. See, this is vertical line. P of T, or other way we can write like this. So T vertical line P. P means here condition of T. where T is the resulting tuple. This is the result. Here T is the result. Here T is the result. Okay, T is the result. Resulting rows. Resulting of rows. Resulting rows. P of T is the condition. P of T is the condition. P of T means that is the condition. Condition used to fetch T. We are fetching the T. We are using condition here. Fetching T, condition we are using. The result will be storing in T. Okay, this is the meaning of this notation. So P of T is the condition used to fetch T, and the resulting tuples will be available in T, this T. Okay, for example, so T dot, here T means tuples. Okay, T dot name, we are finding the name, vertical line, author. Here table name is what? Author of tuples, and T dot article. This is the variable name, attribute name. T dot article. So article row, column having database. That means what? This example meaning is what? We are finding name from author table where article equal to database. Where article equal to database. So this is the output. This query selects the tuples from the author relation. From author relation, we are finding the tuples. From author relation, we are finding the tuples. We are fetching the tuples. It returns tuples with the name. It returns tuples with the name. So result. This is the result, right? It returns result tuples with the name from author table, from author table who has written article equal to database, article on database, who has written article as database. This is the meaning. Okay, you need to write like this. Here TRC, tuple relational calculus, can be quantified. In TRC we can use existential symbol and universal quantifiers. This is the symbol. So this is there exist, we will say, and this is for all, right? So that means existential and universal quantifiers we can use. Okay, for example, see here, relation or table, there exists T belongs to author. From author's table, where condition is what? Article, where article equal to database and name equal to name. Okay, where name equal to name. So output, this query will yield the same result as previous one. So whatever we have the result from this one, so this one same. Also the result will be same. Okay, understand? You can write the query slide. Coming to next relation. So next relation is what? Domain relational calculus, DRC. So relational calculus, two types, tuple relation and domain relation. Here we are representing domain relation. Domain means range of integer, float, whatever the data types we have, right? So the data types. The second form of relation is as domain relational calculus. In domain relational calculus, filtering variable uses the domain attributes. Filtering variables are uses domain attributes. So domain relational calculus uses same operators as tuple calculus. What are the operators we have used? So that same operators we can use here also. It uses logical connectives and are and not symbols. It uses existential and universal quantifier. This is for all symbol and there exist to bind the variables. See the notation how we can use the domain relational here. A1, A2, A3 and so on, AN. Then vertical line, the peak having A1, A2 and so on, AN. See here A1, A2, AN, what are those? Those are attribute. So here P means what? P stands for formula. Okay, built by inner attributes. What is the formula we are writing that represents here? We can represent here. Okay, for example, here we are giving the attribute names: attribute, article, place and subject. Okay, vertical line. Then there exists that belongs to DBMS is the data. DBMS is the table name, and the subject is database, where subject is database used and condition here. Okay, so we are retrieving data article, we are displaying attributes article, page and subject. Okay, from which table? From belongs to DBMS table, and the condition is what? Where subject equal to database, that type of data I want to display. So there I can use this one. Okay, this is important. This query will yield the articles, means display the articles, page and subject from the relational DBMS, where subject is database. That is the meaning of this query. Okay. So in that way we can explain about relational calculus. So two types: tuple relational calculus and domain relational calculus. Right. So next day we will go through some examples. Okay, out of examples there I can explain the relational calculus and domain relational calculus examples. Okay, we will see in tomorrow class. Okay. Do you know how to execute in Notepad these programs, procedures? Yes, all of you. Just write program. So already I explained this. Use edit, then file name. So it will open like this. Then write the PLSQL program. Okay, create or replace procedure name, and number name is begin. We are going to insert the values into user table. So for that we need to create user table here. So if you want to do like this, uh, you need to close this one. So first I need to save this file, save as. I'm going to save in desktop. What is the name I have given here? CSV1. CSV1 dot. Okay. Uh, Let us check whether the table is available or not. User table, user ID and name. So what is the query to know what are the tables available here? Do you have any user table? No, right? Create one user table, create table, user having ID and name, ID number, comma, varchar. Invalid table name. Why? Create table name, ID number, name, varchar. Name is already used in existing object. Okay. Select star from user. Invalid table name. Select star from user. There is no user table, but it is showing already used existing object. Table name, user 3, varchar 220. Table created. Insert one data. Insert into user 3 values of something. The inserted values. I created one table, user 3. So now open that procedure. This is our procedure, right? So our table name is what? User 3. User 3. We are passing values, ID and name. Save this one. So I saved one here. Next, how to execute that at the rate properties. This is available in this location. Copy that, can paste here. Okay, desktop slash csv1.sql. Okay, so procedure created successfully. Then how I can pass the values to call the procedure, so same thing here. I'm going to create another edit, call something, that's your wish. Okay, so same program to call the procedure, begin, end. Then we are passing values here to the procedure. We are passing values. Save this also, save as. So what is the name we have given there? My call dot my call dot sp. Okay, save this one. Then if you close this one, we will get SQL. Now how can I call that one? Go to that location, file location. Where is it? My call. Copy the location. Okay, at the rate how to paste. Right click here, go to edit, paste option, paste. Then name is what? File name my call dot sql. Okay, it is executed. So we can display message record inserted successfully. Are you understanding? Yes, all of you. Have
Yes,
you
sir.
executed any PLSQL programs? That is very, very important. You need to execute it. Okay. So whatever the files, we can take individual, like I created two files here, my call file and other file is what? csv1.sql. I created two files. Okay. Otherwise, I can write the same programs in one file, one notepad file. Then I can call it, I can execute it. We have number of ways to execute this program. Okay, try in different ways, by using notepad, by using PLSQL, our SQL command line, by using SQL developer tool. Okay, and in that also you can use different ways. Write one program in one file and write calling program in another file, then execute it. What will happen? How we are getting the output? Okay, for this directory we can define a directory. Define dir equal to. Okay, can paste. Define dir equal to. So that means what here? I am storing this path in one variable, that is dir variable. Okay, then at the rate dir slash file name my call dot sql. Unable to open file dir my, sorry, wrong. CAL. My call dot SQL. Define dir equal to c colon slash user slash run. My call. This should work. I think something wrong here. Okay, in this way also we can execute. Okay, you try it, ma. We can store the address also in one variable. You can define it. You can assign in dir. This is like a variable. So that reference we can use here. Then we can do. Get dir slash mycall.sql. Okay, no problem. You can try it in different ways. So those are useful in your company, not here. Just for your knowledge, I am saying this. You understand today's concept?
Yes, sir.
What we discussed today?
Outer joins, left outer join, right outer join.
Full out. See, here we have two types of joins: inner join, outer join. In inner join, what are the types of joins we have? Tell me, all of you.
Theta join, equijoin, natural join.
Equijoin and natural join. Okay. In outer join,
Left outer join, right outer join, full outer join.
how we can represent theta join? How we can denote it? Theta symbol. This is the theta
Join
symbol.
with the theta subscript.
So we have two relations, A and B, can represent theta join in this way. So what are the operators we can use here? Less than, greater than, less than, equal to, greater than and equal to, or not equal to. Same thing, whatever symbol you are using here, okay, operators, comparison operators. So if you use equal to, then that will be equijoin. That will be equijoin. The special case of theta join is called equijoin. So use equality comparison operator. Okay, there is no much difference. The natural join means, so you can represent in this way. A table means A relation, B relation. Based on common attributes, both relations perform. So it does not use any comparison operator. We are not using any comparison operator here. So that what we discussed yesterday. See, natural join. We are providing relations and storing here. RHS. You know about this projection and selection? Yes, all of you. What is the use of the sigma symbol?
Sigma selection symbol, it selects the rows.
Selection of it. So selection means, select means tuples.
It works on rows, sir.
Rows.
Tuples are records for
So
selecting.
the rows. Okay. sigma table name, sigma relation, sigma a. That means what? All the table rows and columns, every data we can display. If it is projection means what is the symbol we are using?
Pi.
Symbol. That means what? It represents what? Columns. Okay, that means data. Okay, pi of name, pi of name. That means what? It is displaying name from the table, right? Those are very important, ma. Pi projection and select. Then only we can go through all these remaining topics. Okay. Hmm. Can someone tell me how to get this data? So I want to display the names. See here, I want to display the names of authors who have written book and article. Book and article. This is the question. Then how you can write the relational algebra query? Tell me. Tell me the query. See the question. Find the names of the authors. We are finding names of the author. That means we are displaying author name. So who have written the book and article both? Here book is what?
Book is one table and articles are another table. We are
Another table. So we
selecting
are
author row, author column from
we are,
both the
we are
tables.
combining both tables. So we are finding what? Author names. Okay. So for this we need to write the query like this. Okay. Same thing. Other question. See, I want to display names of the authors who have written the books but not articles. But not articles means which join? We have two tables now here. What tables? Books table, articles table. That means book relation and article relation. So from this table, what I need to display? Names of the authors. Names of the authors. Here the condition is what? The author names, whatever available in the books, I need to display, but that names should not available in article table. That name should not available in article table. So that type of names I need to display. So there we can use minus, except join, you know already, right? Except or minus. Minus means what? Where we can display first table data which is not present in the second table. That's what minus, right? Except or minus. Same thing here. So we are displaying author name from the books table. Those names should not available in articles table. You need to write this query, ma. Okay, try to practice this. So try to analyze number of examples what I given here. So those examples uh, you can practice. Okay. Not get more than this. Do you know cross join? Cross join means what? What is the symbol to represent cross join? We are performing cross join between books and articles. Then condition is what? Where author equal to 4. That all rows I want to display. That all rows I want to display. Whenever if they are asking question in last, who is that? 5D. What happened? See, last year, if they asked about write query for relational algebra, and they have given some theory like that, theory as above. So all are writing. See, if they are asking this question, all are writing SQL query. They lost the marks. They lost the marks. So you should not do like that mistake. Okay. See the question, and if it is relational algebra, you need to write the query like this. You need to write query like this. Okay, don't write select name from authors where something. Don't write SQL query. Write only relational algebra query. Okay, when they ask like this from relational algebra. If it is SQL query, you can write uh, minus operator. Join operation you can perform by using SQL query. Select name from this table minus other table. Okay, right like that. Okay, man, just you revise these topics. Okay, relational algebra and relational calculus. Till now, what I discussed with examples, you need to learn. Then tomorrow, we'll see calculus examples. Okay, relational calculus examples. Then we will start other chapter, other unit. Okay, if we completed this, that means we are going to complete second unit. Okay, do you have any assignment assigned by the sir? Sia?
No sir, assignment ఏమి ఇవ్వలే.
Okay, ma. I will give, no problem. I will give. Then you can submit in our teams. Okay.
Okay sir.